Hello folks and welcome to the Audio Foundry channel. I'm Lanson. So topics of today's video, we're going to cover quite a bit. We're going to go through the Nano tuning tool. We're going to use Room EQ Wizard along with this new tool. We're going to talk about speaker directivity or beaming. We'll talk about crossovers and how to apply some of these topics when using a DSP, and we'll use a Goldhorn DSP in our example. And our first topic will be the Nano tuning tool. Nono is a poster at the DIY mobile audio forums who graced us with this awesome browser-based target curve tool just a few days ago. And I felt that that was really something we should talk about here on the channel. This is just a fantastic tool that I'd like to walk you through. And I'm just going to take it off the cuff as I've seen it, and we'll use my speakers as an example for the tool. Nano wants to give props here to Jazzy's tuning companion for REW. Jazzy is Justin Zazzy, who made a wonderful tuning tool called the Tuning Companion for REW, or Room EQ Wizard. And I have linked this tool before, and I will link it again in the description. Let's dig right into the tool, and we're going to go to nanotuningtool.com, and I've got mine loaded here on, there's the target response tab, and then there's the drivers tab. And I do want to get to the target response feature, but I want to talk about the drivers first, because drivers are things that, the speakers in your car, they're already probably pre-built, or if you're planning out a system, you probably got speaker sizes in mind or limitations that you have to live with. Let's go through that first. So I have a rear sub, front sub, mid bass, mid-range tweeter. I don't have a front sub, so I'm going to remove this. And so you can remove any speaker you need. You can also add new speakers. So our rear subs are 12-inch subs. The low pass, the crossover frequency, here at 70. And I'll link to my mid bass. And it has an LR4 crossover point. LR is Linkwitz-Riley, and that is a crossover type. You have Bessel, Butterworth, Linkwitz-Riley. There are others, but those are the primary. So Linkwitz-Riley 2 is a second order crossover. Linkwitz-Riley 4, fourth order, 6, sixth order, 8, eighth order. Remember, each order changes the phase relationships between speakers. And another way to say them, or the more, I would say, usual way, is that second order is a 12 decibel per octave, fourth order is 24 decibels per octave, sixth order is 36 decibels per octave, eighth order is 48 decibels per octave. A second order slope has a relatively shallow slope here. Fourth order is considered to be a standard amongst most car audio and home audio and pro audio. What that is a 24 decibel per octave crossover slope, and it is in phase with the rest of the signal. And so that's considered ideal for many situations. So sixth order, you can see that it tightens up even more. And eighth order. And so eighth order is the highest that this supports. Now I'm going to take it back to fourth order, and just a little bit of tidbit knowledge for you. Linkwitz-Riley crossovers are two Butterworth crossovers cascaded together. Those crossovers are kind of optimized already. So a fourth order Linkwitz-Riley crossover is a pretty great start, especially if you're not sure what you've got. That would be what you select in your DSP. Back to fourth order, 70 hertz, 12-inch diameter, mid bass. Now we're just going to focus on our front soundstage here for our slopes. So we're going to set our mid bass, as my system has, an 8-inch mid bass in the door. Now I have my crossover at 275 hertz low pass. My mid range goes from 275 and all the way up to 7,000 on my low pass for my mid range. So the cross point is 7,000 hertz. Tweeter will be from 7,000, and the diameter is 0.59 inches. It's a smaller tweeter inside the mid-range. What we're seeing as we work through this is once you enter in the right diameter, you'll get a beaming approximation chart, which gives you lots of information in a very, very small spot here. Think of your speaker here on this plane, and just firing forward would be a 0-degree angle. And then off here would be a 30-degree angle, and then a 60-degree angle, and then a 90-degree angle. The beaming line here, or this curve, represents the response at this crossover cutoff point. At the cutoff of 275 hertz, this response, and it shows here at the bottom, it shows the diameter, shows the frequency, and then it gives some information on the beaming approximation details. If we take our mid-range, we can see that we have a much different visual here. This tool is helpful because it's actually able to show you where a speaker is not optimal for being off angle in a system. This speaker from 275 hertz to 7000 hertz, this response at 7000 hertz is a low directivity response. It's very much a beaming response. And you can probably see this curve here goes inward, and this forms a null. Now, nulls mean that at this frequency, you probably can't hear anything if you are this angle, which is about 45 degrees, away from the speaker. Now, let's take this down. As we make our way down to, say, 5,000, we can see that it's getting a little better and there's no longer a null, but the performance is much reduced here compared to, say, the full circle. And what that means is you will hear it with less total volume at those frequencies than you would the rest of the response that's not beaming. So let's take this down to ideal beaming, which is somewhere in the green. That's why it's color coded. So something like this. Ideally, a 3-inch mid-range passing at 2600 hertz crossover near the cutoff point. That's about what a 3-inch speaker can do. When you're dealing with crossover points and beaming, a couple ways to handle this. If the speaker is on axis, meaning it's facing you, beaming is not really important. But if it's off axis, such as a speaker in the door, it becomes very important. If you're sitting, let's say on the driver's side, the left speaker, this is a US car left-hand drive, so the driver's speaker, left hand, it's a much higher angle relative to your ears to listening position compared with the right speaker. So the right speaker might be at, say, 30 degrees, whereas the left speaker may be 60 degrees. That's when beaming can really rear its ugly head, because what will happen is that your left speaker won't have as much high frequency response as your right speaker. If it's off axis, it's something you need to concern yourself with. If it's on axis, it's not a very big concern at all. With my system, my mid-range and my tweeters are pointed straight up out of the dash. They're reflecting right off of the glass of my car. This reflection does create some frequency response differences, but there's really no off-axis concern with the speaker. For my mid-range and my tweeters, the response from about 0 degrees to about 15 degrees or maybe 20 is what we care about. Now, every system's different. That's just my system and the way it's set up. You may find that your system has totally different requirements. Use the beaming tool to get what you need and to understand what the system's limitations are and how to overcome them. So let's cover an example that is real life and common. It would be a mid bass with a 6.5-inch speaker and a tweeter. So I'll just remove the mid-range, and the tweeter, let's say it's a 1-inch tweeter. The mid-bass could be, say, from 80 hertz to 2000, and the tweeter will take over from there. We'll link it. So what you can see here is at 2000 hertz, the mid bass is starting to lose performance right around 30 degrees in. You would want to make sure that if you're using a 6.5-inch mid bass in your doors, say, if the angle exceeds 30 degrees relative to, say, your driver's ear versus your passenger ear, you would want to adjust the frequency response, if you can, for your crossover point for the tweeters. And I'm just going to take this down and show the difference. So if you could get a tweeter to play, say, at 1500 hertz, the response is going to be stronger at that lower point with the 6.5-inch speaker. But it does depend on the tweeter. The tweeter size is definitely going to have an effect here, because obviously the bigger the tweeter is, the lower frequencies it can play, all else equal. If that were the case, you have a 1-inch tweeter, you can see that your on-axis response at 20K, it's pretty narrow, and that's expected. That's pretty common for a tweeter. And likewise, if you take this, say, to 15,000 hertz, which is about where some people can hear cleanly, you can see that the response is a little better here, up to about 30 degrees. This is why it's usually good to mount a tweeter either on axis or nearly on axis relative to your ears, or bounce it off of the windshield, and so that direct energy at 0 degrees bounces off and reflects into the listening cabin area. This is also why typically people do recommend using three-way speaker sets, because this helps with the beaming issue, as you could have a tweeter that's say 3/4 inch, you could have a mid-range that's say a 3.5 inch, and a mid-bass that's say a 6.5 or even an 8. I'll go back to 8 as my example. And you would set a crossover point where the response, let's say at 3500, so 500 to 3500 for a 3.5 inch speaker, is pretty common. You can see that the response is pretty strong here up to about 30 degrees. And if you push this a little further down, say 2500, now you have a good response near 60 degrees, and you could even use it almost 90 degrees with a 3.5 inch speaker, 500 to 2500. And then you would just simply get a tweeter that can handle that, and you would try to keep that tweeter on axis. So now we know about beaming. Let's go into how we can use the rest of this tool to our advantage. So I'm going to go ahead and reset these drivers and put my system back in place. So we have our speakers. Now let's talk about importing our target curve. On the left, we can see that there are curves that are available to us, and we can, if you look to the right, you can see the dotted lines. This represents that curve, and we can click on it and kind of see what they look like. In a car scenario, half Whitledge curves are pretty good choice for nice impactful response, very flat overall. You can see that it's just a gentle slope down. The Harman curve by Harman International is pretty much world famous. It's a little bit shallow, a little soft, but not bad. The JBL curve is not really a curve, it's just a sharp angle here, and this is not what I would consider ideal, but you could use it as a starting point. Audio Frog curve made by Andy, who is a former Harman guy, now works on his own for Audio Frog. So Andy's curve has a great response overall and is a good starting point if you needed somewhere to start, didn't know where to begin. There are other curves here. I want to talk a little bit about the Resonix curve. So Resonix, that is Nick's brand, and if you go to his website, you'll find that he has his house curves available, and this is actually a really popular curve lately. It's very punchy here in the mid bass for sure, and then soft coming down here to about the 2.5 to 3.5 range. This is nice on the ears, especially listening over long periods of time. Now, I built my house curve, which I'll import now. I built it off of Nick's curve as a starting point, and I do recommend you operate with that. You find a curve that you like and then tune from there. In worst case, you can always come back to your original curve and try again. So we're going to import a curve with this import button here, and we're going to bring in my latest curve, which I have now loaded, and it has 16 points of data, and I'll choose this auto adjust gain. There we are, there's my curve. And then Resonix curve, you can actually see them side by side. The only thing I'd say here is that because this one is normalized, this looks higher, but in reality, it's actually not. It's just 0 decibels is here, whereas my curve dips here. But it's basically the same curve. So let's talk a minute about these definition points here on the left. These are designed specifically so you can look at each point, and they're numbered, and then you can make adjustments or you can add more points to smooth out the curve. So as a for instance here, you can see if I move away that right around here, it is a little abrupt. And so if you wanted to smooth this out a little bit, you could double click or single click even just to add a point, or if you right click, you can remove a point. And what I'm doing here is I'm adding a few points and then smoothing out this response just a tiny bit. There. Now, this tool also brings in an extra nice feature of this easing, these options for easing. And I think the best way to demonstrate this is on point 18. If we look at point 18, scroll down, we see it's at 13,000 hertz, and we can see 3 more options besides the point to point. And so I'm going to click this one here, This is like an S curve. And this adds extra definition to the curve without adding extra points. This curve is more like a half pipe. And this curve's the opposite, more like a waterfall. So if you're in doubt of what to use, I think just point to point works fine. And then you could simply make more points to smooth out or extend the response from where you were before. There's really nothing wrong with adding more points or just changing things up. Just remember that when you make changes to a curve, what you're trying to do here is go for what sounds good to your ears and is good for your speakers and good for your vehicle or home, whatever it is. Typically, on curves for cars, the mid bass response ramps up and meets the subwoofer response because around here is where a lot of our road noise gets masked by our systems. And of course, we do like it lively in a car, so it engages us. And that's where this comes from, is this nice slope. Okay, this looks really good to me. So let's go to the next steps here. We can see that our responses to our drivers are relative to this curve and they're matched up. So this has to do with our frequency responses. So if my sub needed to move from 70 hertz to say 90 hertz, then this is the response that I need out of my speakers to maintain my curve. So once you have your curve set, then you can work on your speaker response relative to that. And this is helpful because if you see, let's go to 60 hertz. If you see this spike here, this means that in order for my mid bass to keep up with my curve, with the subwoofer being pulled down to 60 hertz crossover, the mid bass is going to have to work much harder, and that may or may not be what I want. So you can see as I take it down, that's a pretty significant change. And then likewise, the mid range, say here, we can see I want this slight jump here. And in order to get that, my mid bass and mid range are crossed at 275. And if I move it, you can see that both of them are sharing that crossover point to get what I want. Now, I could go with a higher crossover point, but what I like in my system is I like my mid range, which is in my dash, to carry most of the, I'd say, lower mid range, upper mid bass response as much as they can handle. And that's because it sounds much more impactful and live at the front of the car. So every situation is going to be different. Just adjust these how you need for your performance. So we've got our target response set, we've got our points made, and we've got our drivers set. We've got the crossovers. We know our beaming approximations. Now it's time to get this curve either out to other people or to export it and show what this tool can really do. So first I'm going to do is share my curve to myself. Okay, so let's talk about exporting curves. When we hit export, we can choose our curve and then we can choose which drivers we're going to export. And I'm going to export them all, and I'm going to export it in REW format or text file format. If you have ATF format, what that means is that's a Helix processor, Audio-Tech Fisher. We'll leave the gain response or gain offset rather at 0. We'll export now. And you know what I'm going to do? I'm going to name this one. What I'm going to do is I'm going to name this with a fresh name so I don't lose track of what I'm doing. Let's export this now. And so what it's doing is now putting in curves for all of my different speakers. Okay, before we leave this, what I'm going to do next is come in here to the drivers, and I'm going to work on my rear speaker setup because I want the same curve on the other speakers that I have. So I'm going to set this up real quick. Now, I'm going to remove the tweeter here because my mid bass is actually a component set in the rear of my doors, my rear doors. So they are set at 80 hertz crossover, and there is no low pass because it's just a component set with a passive crossover. In other words, I don't have control over the crossover point except for the sub to rear speaker. And so this response curve now will become the curve that I'm looking for my rear speakers. And I will name those rear components. So we're going to export that. There we go. And I've got one more to make, and that is for my center channel. I'm going to leave the sub out of it. And my crossover for the center channel is 200 hertz. And I do have a tweeter in there too, so I'll add the driver. So the center channel will be 200 to 7000, and this driver will be the center tweeter. Now I have the same target curve, but for my center channel's unique requirements. Okay, all done. So the tool, it's taking care of everything we need to for now, and I'm going to go ahead and close it. And I'm going to go ahead and load up the Goldhorn DSP demo. I'm going to use the demo because I'm nowhere near my vehicle right now, so I don't want to load. I don't want to load the main program, as I won't be able to connect to my car. So what I wanted to demonstrate for Goldhorn users is how the crossover limitations of Goldhorn will affect you compared to what you just saw from the Nano tuning tool. So we'll just pick a speaker and we will give it a high pass and low pass filter. And we can see that we have Linkwitz-Riley, or Linkwitz they call them, but that's a Linkwitz-Riley filter, Bessel and Butterworth options. So if I pick Linkwitz, I'll be able to pick my frequency. Let's say the low pass will be 80 hertz, right, like a subwoofer. And we can see here, we'll just turn this one off. We can see here by this response that I have a Linkwitz-Riley 12 decibel per octave, which, as we now know, that's a second order crossover. And so we can see that Goldhorn, at least this model of Goldhorn and this level of software, like the version that it is, we can see that there is a 24 decibel per octave option. And we can see that slope shift here. And we can also see a 36 decibel per octave. What we don't see is a 48 decibel per octave. It's actually not supported. What is interesting, and maybe you can use this, just decide, is the Bessel curves. They do support up to 48 decibel per octave, and so do the Butterworth. And so remember that Linkwitz-Riley and Butterworth do have a relationship because a Linkwitz-Riley crossover is a cascaded Butterworth combo. There is a phase relationship, there is a response relationship to crossovers. It does apply in the digital domain with a DSP, as it would with the analog domain of running a passive crossover with inductors, capacitors, resistors, and so on. But what we're wanting is a phase independent response. We don't want to have to adjust phase just because we change a frequency slope. So that is why oftentimes we will stick with the Linkwitz-Riley 24 decibel per octave standard. And that's actually what I'm going to recommend for most Goldhorn users and most DSP users in general. But if your DSP supports 48 decibels per octave Linkwitz-Riley, consider it as an option for extremely steep slope scenarios. And the other slopes are still good, but you might need to deal with phase adjustment. And what that would be is adjusting phase here. Like say, for instance, if this is 36 decibels per octave, you might need to phase correct whatever it might be to reach there, depending on the polarity of the next speakers in your system. This gets complicated, probably worthy of a separate video, so I'll leave it there for now. And we'll just say 24 decibels per octave Linkwitz-Riley is recommended for a phase independent crossover. Let's go with that. So let's get out of Goldhorn since we've got what we need here. And we're in Room EQ Wizard now. We're in the main screen and I'm going to go to the EQ screen now. Okay, so we're just going to show how to put house curves in. You will go into the EQ button and choose here on the target settings house curve and select your house curve, and there it is. And we'll just leave the target decibel range at 80, but you could change it if you needed to. This is not really important right now, but we do want to hit generate measurement from target shape and make sure that your target type is set to none here. There we go. Now what it's done, I'm going to minimize this. What it's done is put a response here on the main screen for Room EQ Wizard. And I'm going to label this now with what I want. So this was my 713 curve. I'm going to overlay a few extra curves just for a discussion on what these different curves mean. I'm going to load the audio frog house curve. Following the same process, make sure the target type is none, and generate measurement from target shape. And then I'm going to load the latest Resonix Nix curve from just June of this year. There it is. And we'll just generate a measurement from that one as well. Now I'm going to go name these before I forget which ones they are. Let's talk about these curves in an overlay. So I'm going to hit overlay here. And what I'm going to do is use this adjustment here and create an action for each curve. And I'm going to seek a balance point for all of these. And I'm going to say 100 Hertz is my balance point. That's where the point where they're all mixed together at the same SPL or close to it. So I'm going to bring up the audio frog response. I'm going to make this a little bigger so I can see what's going on. And we will take it right to this 100 Hertz point is my focus point. And I'm going to take the Resonix curve and match it as well. Nearly as, I think that's probably as good as we're going to get. So why I wanted to show this is when you're looking at house curves or target curves, whatever you want to call them, it's all relative to another curve, right? And so what you can see here is Audio Frog's, this green curve here. It's got a lot of mid-range from about 400 Hertz all the way to about 9 to 10,000, even up to 13,000 Hertz. There's this big band over. Now, that's nice, but in a car, it could be a little bright or it could even be kind of irritating on the ears. But, you know, your mileage may vary. And then we can see Resonix curve, that's Nick's curve. You can see the mid bass climbs, levels out, and he has a nice drop here from about 400 Hertz all the way to about 3000. And then my curve, I have slightly a punchier mid bass to the sub. And I've done that because my subwoofer is an infinite baffle pair of 12s. They can play very, very low, very cleanly. And so I like that nice fat mid bass, lower sub response. It feels really good in the car. The rest is very similar. And then I've got a little bit less mid range, not much. And then my upper mid range is almost the same. And then I've got a little bit more sparkle on the top end, just a bit. Let's talk about those curves that we brought in from our response plots for the bass, or for the subwoofer, for the mid bass, mid range, and tweeter. So I'll load those now. So we're going to bring in the rear sub. We'll bring in the mid bass. We'll bring in the mid range and the tweeters. The next thing I'm going to do is I'm going to bring in my rear speakers. And I'm going to bring in my center channel. Okay, so I'm going to go ahead and minimize this, and I'm going to label all these curves one moment. What I've done is adjusted my limits. And we can see now, and I'm going to go ahead and remove some speakers here to make this more visible. I'm going to remove all my center and rear components. So we can see that there are curves now for the subwoofer, mid bass, mid range, and tweeter using that Nano's tuning tool. And so now the curve, my desired curve, let's go find that. The one that doesn't have any modifications. Okay, so what we can see on screen is I have the target curve of everything that was done in the Nano tuning tool. And then we can see underneath it the individual curves for each speaker. So how this is used, we will save all of these here for REW. We're going to save this in our house curve folder. Now we have our curves that we can use to help build our system response per speaker. And so we can get the total performance of all speakers and have that curve as well. So let's call out exactly how this works in real world. So I'm going to pick and close all of these down, and I'm just going to load my target curve for my front mid-range. And so this response right here is what I want when I'm doing my EQ work and my tuning work. I am going to get this mid-range curve as my target. So we would take this as our front mid-range, click on it, choose EQ, and get this so it's in line with the rest of our goals. When we're doing measurements, we would build relative to this curve. Let's see if I can give an example of that. So I'm going to load some old measurements. Okay, so I loaded some old measurements here. Let's take into mind here, I'm just going to close out and remove a few of these files. Okay, I've left just two curves in place, and I'm just going to adjust my limits here so it's easier to see. And what I'm going to do next is I'm going to adjust these in the overlay. And next I'm going to adjust the output here so they're a little easier to see what's going on. Okay, what we have here is an older response before I made some EQ changes. We are looking at the raw response here, smoothed out, of one of the speakers, the front mid-range, and we can see that there's a dip here. So the goal of this is to get this response of this mid-range speaker to match this mid-range curve right here. But the beauty of doing this with the Nano tuning tool is that unlike running your EQ work from your main curve, you're doing it from the curve that corresponds to the speaker that you want to set up an EQ. And what that gives you is much, much better control over that individual speaker response plot that you want to EQ out versus the whole curve because of those crossover points. As a quick example, let's load these up. We're going to load our, looks like it already preloaded, so that's great. I'm going to choose target type speaker driver here, and I'm going to adjust my crossovers to match my slope for my mid-range. So that was a 275 hertz crossover, Linkwitz Riley 4, with a 7,000 hertz crossover, Linkwitz Riley 4, and I'm going to drop this response relative to the performance of the speaker itself. And I would say right about there. And we will give it an ability to match from about 190-ish to about 11,000. Okay, let's try this again. Much better. There we go. So now our predicted response is that nice soft curve that we can see. And then, assuming this response is what we want, when we apply this response to the rest of our system, we will have a total summation for our house curve that we want. And that's what this tool is doing for us. It allows us to take our house curve, tweak it if we want, and then set it up so each and every one of our speakers gets a chance to be set up with the right filters that are just perfect for the crossover slips we've elected to use. And we would simply take these responses and put these into our DSP. Okay, well, I do hope you enjoyed the video. Like and subscribe and all those things. And thanks for joining me on the Audio Foundry. Take care.